Hello and welcome to helpyourmath.com. In this video, we're going to look at polynomial products and special polynomial products. First, we're going to look at multiplying a monomial to another polynomial, either a binomial or a trinomial. In order to do this, we apply the distributive property of multiplication over addition or subtraction. So we might have A would be our monomial, and then maybe we'll make that B plus C. B plus C would be our polynomial. And so what we're trying to do is we're trying to say, well, wait, I can't actually add B and C because they're not like terms, but I would like to remove the parentheses. So the distributive property is kind of a way of bypassing the order of operations. What we do is we take the factor that's on the outside and we multiply it to every term we see inside. So there's two terms because I just see that one plus sign, and we would multiply A to the first term and we would multiply A to the second term. If there were three terms, A would get multiplied to the third term as well. Okay, and we want to keep in mind that when we multiply polynomials and monomials, the numbers we multiply like regular numbers, but to combine same base variables, we use that same base multiplication where we'll add the exponents. So let's take a look. We have this monomial, just this one thing, negative 3g squared, and we want to multiply it to the three terms inside that set of parentheses. So first up, we're going to multiply negative 3g squared to 2g to the fourth. A negative times a positive will be negative, so this first term will be negative. 3 times 2 is 6, and g squared times g to the fourth. Remember, we're going to add those exponents. We get g to the sixth. Next up, we're going to take negative 3g squared and multiply it to the middle term, which is negative 3g squared. Hey, it's the same thing. A negative times a negative is positive. 3 times 3 is 9. G squared times g squared. We would add those exponents. 2 plus 2 is 4. And then last up, we're going to take negative 3g squared and multiply it to 1. This would just give us minus 3g squared. Because there were no like terms in the parentheses, there probably aren't like terms here, but it doesn't hurt to check. No, because the g's all have different exponents, and this would be our final product. Remember that a product, that is the final answer of a multiplication question. In this next example, it says find the product. Again, product means multiplication, and we're given this trinomial. So this is one of the two things we want to multiply, and here's the monomial we want to multiply to it. I might just rewrite it, so I put the 5x in front times 3x squared minus 2xy squared minus 7. And this time we're going to take this 5x and multiply it to, again, we have three terms. So we're going to multiply it first to the 3x squared. 5 times 3 is 15. X times x squared is x cubed. Next up, we have 5x times, and then we have negative 2xy squared. A positive times a negative is negative. 5 times 2 is 10. X times x is x squared, and we'll bring down that y squared. And 5x times negative 7. A positive times a negative is negative. 5 times 7 is 35, and then we just bring down that x. All the variables, I see no like terms, so this would be our final product here. So this is multiplying a monomial to a polynomial, but what about when we have a polynomial times a polynomial? I know of 4 methods, although I'm sure there are more. I tend to use option 3 the most frequently, but I can show you all 4, and then if you like one of the other ways better, of course you can use it. It's going to work out whichever way you prefer. So option 1 is double distribution. So it's kind of applying what we did here and just rewriting one of the polynomials into factors of its monomial. So let's see, I'm just going to do an example. Let's do x plus 4 times x plus 6. I'll just use this for all 4 methods, and again, you can see which method you like the best. Okay, so option 1 is double distribution. So we're going to write x plus 4 times x plus 6, and in double distribution, we kind of do the same thing here. We kind of broke apart the second term as we distributed the first term. And so what we would do here is we're actually going to kind of go in reverse. We're going to break apart the first term. We're going to say, okay, I need x in the first parentheses to get multiplied to x plus 6 in that second parentheses. Plus, I need 4 to get multiplied to x plus 6. So it's kind of just making sure that both terms from the first factor get multiplied to both terms of the second factor. And now, just like we did on the previous slide, I can distribute each of these monomials. X times x is x squared. X times 6 is 6x. And that's it for the first one. The second one, we have 4 times x would be 4x, and 4 times 6 would be 24. Then I would look for like terms, and I actually do have like terms this time. And when we normally have binomial times binomial, it's pretty common that we do have like terms. The like terms are these middle ones. So our final product here will be x squared plus 10x plus 24. Just one small note as I go through this. So I kept both binomials to have plus signs. If, let's say it was x minus 4, then when we get to this step, we would be distributing a minus 4. So we would have minus 4 times x and minus 4 times 6. For the multiplication algorithm, this goes back to like multiplying 2-digit numbers and 3-digit numbers. You can kind of do the same thing with polynomials. So we could set it up as the first factor times, I'm just going to use a dot since I have x's in here, the second factor. And just like we did with, if these were like 2-digit numbers, we would do 6 times 4 is 24. 6 times x is 6x. We'll keep the, in between these, there's going to be a plus sign because I multiplied a positive 6 by a positive 4. And then when I do my second row, remember when you're doing 2-digit multiplication, usually like scooch you over a space because now you're multiplying by like the tens place. What we do here is we line up the like terms. So when I go to multiply x times 4, the 4x is like terms with 6x, and then x times x is x squared. And now I can add straight down x squared. This would be a plus 10x because both 6 and 4 are positive, plus 24, and we see it matches. So that's using the multiplication algorithm. We still get the same product, which is good. I mean, that's the point. We should be able to choose what method we use, and we should be able to get to the right answer. Option 3, this is the one that I use most frequently. The thing is, if it is like a trinomial times a trinomial, this can get messy, and you might want to maybe also do at least part of option 1 if it comes to that. So arcs and arrows is just kind of saying, I'm just going to show that I'm going to multiply each term from my first binomial or from my first factor. I'm going to multiply those to each term in my second polynomial. So I'm going to start with x. I'm going to do x times x and get x squared. X times 6 and I get 6x. Next up 4. 4 times x is 4x. And 4 times 6 is 24. Then, as I have been doing, I would combine my like terms, and we get x squared plus 10x plus 24. So again, all of these methods are basically doing the same thing. It's just, you know, how much work you want to show, what makes the most sense to you. And this brings us to option 4. Option 4 is FOIL. I did put an asterisk because it is a special one. FOIL is just an acronym. So it's just to help us remember what we multiply if we have binomial times binomial. So FOIL only works for binomial times binomial when multiplying two binomials. And so each letter in FOIL stands for something and is telling us what to multiply. The F stands for firsts, in that in each binomial, we multiply the first terms together. The O stands for outer, and that just means take the first term and the last term and multiply those two terms. The I stands for inner, and that's not the outer ones, but the inner ones, the ones that are like right next to each other, except there's two parentheses between them. And then the L stands for multiply the two last terms of each binomial. So if we look at this, I can apply it here, right? I can FOIL because I have binomial times binomial. The firsts just mean multiply the first term times the first term. Outer, take this outer one, multiply it to the other outer one, we get 6x. Inner, we do these two, plus 4x. And the lasts, the 4 times the 6. So you can see FOIL is exactly the same as option 3. It's just an acronym to help us remember what terms get multiplied to what terms. We combine our like terms, and yet again, we get this x squared plus 10x plus 24. One quick note before we get to some examples. So we just went through some options of how you can multiply these polynomials. And if you ever do this, either x minus 5, that thing squared is x squared minus 25, Or if you just do x squared and minus 2 times positive 4, I'm sorry to tell you, but a puppy dies. Let's save Beamer and all the puppies out there. Please do some good math. Now, the top one, you might be saying, I don't see what's wrong with that. You distributed the exponent. But here's the thing. You can't distribute an exponent over addition or subtraction. We're going to look at a shortcut you can use, but that's not it. Let's keep the puppies alive. Let's do some good multiplication. Okay, so in each example here, we're going to decide which method to use. I always encourage you, pause the video and try it for yourself first. Okay, so for the first one, you can use any of the 4 methods we talked about. I'll use FOIL just to really emphasize those initials in case you're trying to commit it to memory. So for FOIL, that's just a shortcut for saying I'm going to do the distributive property. And first we multiply the first together. So that's 9y times 8y. 9 times 8 is 72, and y times y is y squared. Now we have outer, that's 9y over here to positive 3, gets multiplied to positive 3. That becomes positive 27y. Inner, we have minus 1 times 8y. That would be minus 8y. And last, we have minus 1 times 3, minus 3. Now we look for those like terms. They're right here in the middle as they usually appear, and we get 72y squared. This would be plus 19y minus 3, and that's our final product here. Next up, we have a trinomial times a binomial, so we can't use FOIL. We have to use one of the other methods, whether it's the arcs, or if you want to distribute, I would distribute the rewrite the a and the minus 8 separately, whatever makes sense. I'll color code it so that way it's very clear what's getting multiplied. But there's also a hint. So when I'm taking 3 terms and multiplying it to 2 terms, when it's unsimplified, I will have a total of 3 times 2 terms. So I'll have 6 terms. That's kind of like a nice check to make sure you got all the terms and you didn't like do one of them twice. But let's see. So we're going to start with this 12a squared. And we're going to multiply it to the 2 terms in the binomial here. 12a squared times a, I have 2 a's here, another a is getting multiplied, so that's 12a cubed. 12a squared times minus 8 would be minus 96a squared. Next up we have this minus 2a. So minus 2a now gets multiplied to the 2 terms in the second factor. Minus 2a times a would be minus 2a squared. Minus 2a times minus 8, well, a negative times a negative is positive. 2 times 8 is 16, and we end up with 16a. And lastly, we're going to distribute the minus 3. Minus 3 times a is minus 3a. Minus 3 times minus 8, negative times negative is positive. 3 times 8 is 24. So, do we have 6 terms? Yes, we do. Hooray. So I feel good that we got all of the terms that we should have, and we don't have extras. Next up, we're going to look for some like terms. Conveniently, they're right next to each other. So there's an a squared, and there's an a squared. I should have started with the 12a cubed. It had no like terms. I got so excited to use my highlighter, I forgot. So we have 12a cubed. Then we want to combine the minus 96a squared with the minus 2a squared. They're both negative, so it'll still remain negative when we combine them, and we get minus 98a squared. And then we have minus 16a and positive 16a and negative 3a. And when I combine those, positive 16 and minus 3 make positive 13a. And the 24 is the only constant, so we'll just bring it down. And here we have our final product when we multiplied the trinomial by the binomial. You might have thought we were done, but we're not. We're going to look at some special cases. Think back to the puppy. Let's do good math here. First up, we have m minus 4 times m plus 4. You might be saying, well, what's special about this? Let's see. You can use any of the 4 methods because it is a binomial times a binomial. I'll FOIL again, so that's m times m is m squared. M times positive 4 is positive 4m. Negative 4 times m is minus 4m. And minus 4 times positive 4 is minus 16. When I go to combine my like terms in the middle, I have a positive 4m and a negative 4m. Well, that adds up to 0. Because I have other terms, I don't need to write the 0, leaving behind a final product of m squared minus 16. And if we think back, when I multiplied a binomial times a binomial here, I ended up with a trinomial. And that is common. Normally we have the m squared, just the m, and then the constant, but here they canceled each other out. And we're going to see in just a minute that m minus 4 and m plus 4 actually have a special relationship with each other. We'll hold off on that. I'll save the surprise for later. Let's look at the middle one. So the middle one, here we go. We have the exponent, but it's over subtraction. If you need to, just do what the exponent says. The exponent says, write the base twice. So this would be 4x squared minus 1 one time, times 4x squared minus 1 twice. Now that I've written it twice, I can FOIL, I can do distributive property, whatever we want to call it, that's what needs to happen. So I'll FOIL, I have my first term here is 4x squared. I'm going to multiply it to 4x squared. 4 times 4 is 16. X squared times x squared is x to the 4th. Now I'm going to take the 4x squared and multiply it to the minus 1. That's just going to change the sign to a minus 4x squared. And then same thing here, I have a minus 1 getting multiplied to this 4x squared. That's also a minus 4x squared. Minus 1 times minus 1, a negative times negative is positive, and 1 times 1 is 1. I can combine my like terms. Oh, look, they're the exact same like term. These don't cancel each other out. They just will now become double, and that would be minus 8x squared plus 1. So we see again, I multiplied two binomials, and I ended up with a trinomial. That's the more normal thing to happen. And notice that if you had just distributed the exponent, you wouldn't have gotten that middle term of negative 8x squared. So don't forget the middle term. It needs to be there too. In the third example, oh dear, we have an exponent of 3. Just like we couldn't distribute the exponent in the middle one, we also can't distribute the exponent here. We're going to rewrite it by expanding. I need 3 factors of x minus 3. And I think I've mentioned in other videos, but when we go to multiply, you can only multiply 2 numbers at one time. So we're going to multiply the first 2 binomials, and then we're going to take that product and multiply it to the last one. So we're going to start with this x minus 3 times x minus 3. We can FOIL it, we can distribute. Let's see, x times x will be x squared. X times minus 3 is minus 3x. Minus 3 times x is minus 3x. And minus 3 times minus 3 is positive 9. I will go ahead and just combine these like terms. But remember, this thing is still inside parentheses because it still needs to get multiplied to that last factor of x minus 3. When I combine minus 3x and minus 3x, I end up with minus 6x. And then we're going to multiply this trinomial to this binomial x minus 3. First, I'm going to take x squared and multiply it to x. X squared times x is x cubed. X squared times minus 3 is minus 3x squared. Then we have minus 6x gets distributed to x. That's minus 6x squared. Minus 6 times minus 3, a negative times a negative is positive. 6 times 3 is 18, and then we bring down that x. These all would be on one line, but since I'm running out of space, I'm going to do it beneath. When I multiply this 9, positive 9 by x, I'm going to just say plus 9x down here. And positive 9 times negative 3 will be negative 27. Next up, let's look for like terms. X cubed is on its own, so we just bring down the x cubed term. Next up, looking for the squares, we have minus 3x squared and minus 6x squared. They're both negative, so when we combine them, we get minus 9x squared. Next up, we have the x's. I have 18x and 9x. Whoops, that's going to be hard to see now. When I combine 18x with 9x, I'm going to get 27x. And then just that minus 27, that constant's the only one, so I don't need to highlight that. That poor 9x. Let's bring it back. There we go. And that would be our final product here, or cube, when we cubed the x minus 3. So again, notice I ended up with 4 terms. You can't just distribute a cube over a binomial. That's not how it works. So let's talk about these special products, because all of these were special. The 4x squared minus 1 quantity squared, and then initially we computed x minus 3 squared. Those are called binomial squares. The shortcut here is yes, you square the first term, and yes, you square the last term, but the missing piece is the middle. So you'll notice when we have a binomial square, the 2 middle terms are identical. And how did we get those middle terms? Well, it was by multiplying the outers together, so the 4x squared by the minus 1, or the inners, which is actually just the 2 terms in that binomial being multiplied, and then because there's two of them, we double it. So it would be plus the product of the two terms, x times y, doubled, so we say plus 2xy, and then it's the second term squared. If the binomial has subtraction in it, it's the same thing. We square the first term, we take the two terms and multiply them, but here we have x times negative y, which would be negative xy, double it, which gives us minus 2xy, and then we square the last term, negative y, that thing squared, would become a plus y squared. So now we can use the shortcuts. These are good, legitimate shortcuts, but I will say you don't ever have to use these. If you want to expand, you can expand, right? You could rewrite this as x plus y times x plus y. It's just, sometimes we do these so much that it's like, could I just skip one single step? But you can see here, there's the x squared, there's the y squared, and here are those two terms of xy. Since there's two of them, we can write it as 2xy. All right, so we're going to find the square of 2x minus 5. We could rewrite this as 2x minus 5 squared. Let's practice with the shortcut. The first term is 2x. 2x squared, well, 2 squared is 4, and x squared is x squared. Take the two terms, 2x and minus 5, multiply them, that makes minus 10x, and double it, minus 20x. That would be our middle term, and then the last one is going to be minus 5, that thing squared, gives us positive 25, and this would be our square. To find the square of 3x plus 4, so again, that just means take this thing and square it. Well, that's going to be the first term squared, 3x, that thing squared, will be 9x squared. Take the two terms and multiply them, that's 12x, then double it, 24x, and then square the last term, 16. Keep in mind, so for both of these questions, you'll notice that the first term did have a number. Make sure you're squaring the number, right? Because it's 2 squared x squared, 3 squared x squared. We just want to make sure that we're not missing any of the terms or the coefficients. And the last one was the difference of squares. For the difference of squares, that was the one that we saw that I think it was like x minus 4 and x plus 4 or something. But what happens when we distribute is we get x squared plus xy minus xy minus y squared. These middle terms will cancel. But notice what these are. It's the same two terms, but they have opposite signs between them in the binomials. These are called conjugates. So these two things I mentioned have a special relationship. These are called conjugates. The conjugates are when they are nearly identical, except the sign between them is the opposite. And when we have conjugates, what happens is we get the first term squared minus the second term squared. Again, you never have to apply the shortcut. You can always just get the middle terms, but they should cancel out. Looking at question 16, so 7x times 7x is 49x squared. Then we're going to have a plus 28x and a minus 28x. Those are gone. And then we have minus 4 times positive 4 is minus 16. So you'll notice here, the binomial square is referring to the thing we're given, right? We have the binomial x plus y, and then we're squaring it. Whereas here, the difference of squares is the final result. The difference is a word that indicates subtraction, so that's that subtraction. And squares is referring to perfect squares. 49x squared is a perfect square, and 16 is a perfect square. And then these things would just be called the conjugates, the product of the conjugates. Okay, last up, are these in fact conjugates? Same first term, same second term, opposite signs. So we can just multiply the first terms. 8b squared times 8b squared is 64b to the fourth. And we can just multiply the positive 3 by the negative 3 and get negative 9. And here we have our difference of squares. This has been a video on multiplying monomials to polynomials, polynomials to polynomials, and special polynomial products. Thank you for stopping by.